Continuing with the topic of traumatology or mechanical injuries, this is the second lecture, and we have discussed in the previous lecture the components of trauma. And the components are basically the factors which are responsible for the change in the shape or change in the appearance or the outcome of the force applied, resulting in the change of wound. The components, they are the weapon, the tissue, and the force and the movement. So these are the factors which change the appearance. And we started discussion on the intrinsic qualities of a weapon. What are the qualities within the weapon which make a weapon a blunt, a sharp edge, or a firearm? So these components change the appearance regarding the intrinsic qualities. Then the other next is the force applied. How much force, direction of the force, and various other physical laws which are related with the application of force, they govern. And when the force is applied, the physical laws, Newton's laws of motion, laws of elasticity, laws of conservation of energy, all they result into appearance of the wound. Then the tissue, the subject where it is applied. We know that the human tissue is not, human body is not a uniform subject. It is made up of various tissues. There are cavities, there are solid organs, there are fluid, there is air, the skin, the subcutaneous fat, the muscles. So all have different behavior regarding the force being applied to them and the outcome which will come. So the architectural design of the tissues plays an important role also, which is a major factor in the appearance of the wound. Then the contact area, where is the force is coming in contact? Underneath is bone, underneath is air, underneath is fluid, so that will determine the outcome. And similarly, the target area, sometimes the contact area is different, but the target area, that is the maximum concentration of force, may be at a different place. For example, when a person is falling from height and landing on the feet, the contact areas are feet, but the force is being transmitted through the legs, through the vertebral column to the base of the skull, and there will be annular fracture at the base of the skull. So the target area will be different than the contact area. Now, continuing with the factors or the components, how they change the appearance, we have discussed the intrinsic qualities of the weapon in the last lecture. Now we'll discuss the force and the architectural design. When the force is applied, it is under the laws of motion. And we know that whenever there is force being applied, force is the response, and there is also always a counter response. Force being applied by the weapon and the counter response by the tissues. And we know that it is the amount of force which will determine the counter response. So the interaction between tissues and force, they are governed by the laws of the physics, and they are the Newton laws of motion, laws of elasticity, laws of conservation of energy, and Hooke's laws of elasticity. So whenever a force is applied initially, depending upon the amount of force, the tissue tries to adapt. Tissues try to resist, and a little distortion, little change in the shape may result. But initially there is resistance due to absorption, due to the design of the tissue. And the mass or the tissue, it adapts, but it adapts up to a limit. And then when the limit is exceeded, then the distortion will occur. As I discussed, that the human body is not a uniform tissue. It is made of cells, and the cells, they are arranged in a specific manner in various tissues. And when the force is applied, the cells, they try to slide one above the other. They distort like they are sliding one above the other. That's why they are changing the shape, they are adapting, they are resisting, because there is a space which allows them to a movement up to a extent, and when that extent is needed, then the distortion will occur. So they are under the laws of elasticity, that they are elastic up to an extent. They can slide, they can move by the application of force up to a certain limit. And we know that the amount of energy required to distort is exactly proportional to the amount of distortion. That is, distortion is directly proportional to the amount of energy. They are vice versa, that if the amount of force being applied is higher, distortion will be higher, and if the amount of distortion is higher, naturally the amount of energy applied is higher. But when this limit exceeds, then the tissue disrupts, and the resistance, the adaptability, that is under the laws of elasticity or the Hooke's laws. Now, regarding the amount of force, how much force is applied which can disrupt the tissues, and amount will determine the causation of the wound. This is important factor. And last day I told you that a simple example of a stick on a same place, any blunt weapon like stick, if we are striking at a same place, varying the amount of energy, if we strike with a little force, it may not produce any change. If we increase the change, simple erythema or redness will occur, and go on increasing the amount of strike, amount of force, it will lacerate, it will crush, there will be fracture underneath. So by increasing the amount of force applied by the same weapon at the same site can change the appearance of wound. Stop talking, please. Stop talking, last row. So the same weapon, by varying the amount of force applied, will change the appearance of the wound.